All right, today, folks, we want to investigate the three most common units of temperature and perform a couple conversions going between some of these. So the first thing is, if you start to consider temperature, there are three main scales that we use. We use Celsius, we use Fahrenheit, and we're going to start to talk about Kelvin as well, the absolute scale. Well, the whole idea with temperature is that we're establishing a scale based off of certain points. So the question is, what 2 points can we use as our standard worldwide? Well, if we think about worldwide, where they are performing scientific experiments, we have water. And so where would it be easiest to look at water? Well, it'd be easiest to look at phase changes of water. So we're looking at that freezing point, okay, going from liquid to solid, or the melting point of water, and also looking at the boiling point. All right, so if we were to consider that freezing point of water, using the centigrade scale, it's 0 degrees Celsius, and the boiling point is 100 degrees Celsius. And this is what the rest of the world uses. And then here we use this wonderful Fahrenheit scale, where the freezing point of water is 32 degrees Fahrenheit, and the boiling point is 212 degrees Fahrenheit. And the typical body temperature is supposed to be about 98.6 degrees Fahrenheit. But come to find out, it was actually supposed to be 100 degrees Fahrenheit. They just think that Anders Fahrenheit actually had a slight fever the day that he was finishing up his scale. So that's why we have 98.6 instead of 100. So what will we use in this class, and what do we need to start thinking about? Maybe it'd be a good idea to actually turn your weather app on your phone to start to look at Celsius, so you can start to get an idea of what these temperatures are. So even though we measure most things in this class in Celsius, the SI unit, you will recall, is actually Kelvin. And that's our absolute scale. So what we're going to do is we're going to look at how to convert between these different scales, and then we'll do a couple conversions together. So another thing that I do want to point out to you is, recall that freezing represents going from a liquid to a solid. We also have melting. So if you're melting, you're going from solid to liquid. But what we'll end up seeing is that many times in textbooks, we will see, instead of melting, we will see something that says fusion. Okay, so fusion is used more commonly than melting, and that, again, is looking at going from the solid phase to the liquid phase. All right, so here are the temperature conversions that we will use. This is the one that you will probably memorize and use the most on your own, and this is looking at going from Celsius to Kelvin. If you needed these going between English and metric, so Fahrenheit to Celsius or Celsius to Fahrenheit, I would give these equations to you on an exam. But you have to make sure that you're putting the temperature in the correct place. So in this first equation, looking at Kelvin and Celsius, if you're given a temperature in Celsius and you're asked to find Kelvin, this is where your temperature in Celsius goes, and you're solving for that. And you can rearrange these equations as need be, but just really pay attention to the details. Okay, so let's actually try to plug into one of these equations. So if the temperature in New Delhi is 41.0 degrees Celsius, is that temperature higher or lower than the 103 degree Fahrenheit weather in Phoenix, Arizona? So it actually doesn't matter which temperature you choose to convert. You just have to make sure that you're comparing similar units. You can't compare 41 degrees Celsius to 103 degrees Fahrenheit. You need to get them to the same unit. So let's say that we wanted to convert our 41 degrees Celsius into Fahrenheit. So we want to find Fahrenheit. So that means that we would probably be using this equation right here. So we're solving for the temperature in Fahrenheit. So whenever we plug in, we'll end up getting, so we have that 9/5 factor, which maybe we'll go through in class and look at how we have the units on the slope, times the temperature in Celsius, which was 41 degrees Celsius, plus that 32 degrees Fahrenheit. It's our y-intercept. And whenever we get this, we end up getting 105.8 degrees Fahrenheit. So what does that actually mean? Well, that means that New Delhi has a temperature that is 105.8 degrees Fahrenheit. So it is warmer than it is in Phoenix, Arizona. Well, let's say that you actually didn't want to convert the Celsius to Fahrenheit, that you wanted to convert the Fahrenheit into Celsius. Well, you could do that, but we would use this equation right here. So if we wanted to go from 103 degrees Fahrenheit into degrees Celsius, we would use that equation. So we would have our temperature in Celsius is equal, so we'd have 5 degrees Celsius over 9 degrees Fahrenheit times the quantity, let's see, we have 103 degrees Fahrenheit minus 32 degrees Fahrenheit, and that equals 39.4 degrees Celsius. So this tells us the temperature in Phoenix was 39.4 degrees Celsius. So no matter which way you choose, this ends up giving us the exact same answer. That New Delhi is warmer than Phoenix. And we will go through and we will do more practice problems converting Celsius to Kelvin in class.